All right, it looks like we're live. I'm just going to go check the YouTube page for this, make sure it's working, and then I'll begin my presentation. And that worked. All right. So what this video is going to present is a response to Phuket word, or Phuket word, however it's pronounced. I'm going to show you first conversation from last week when I posted the previous video. This video, I presented his Sunsets on Flat Earth video, and I described some problems with his side-on presentation. Okay? And I create a side-on presentation that matches reality. He takes issue with this. If you're going to illustrate the change in angular size, then change the size of the house. That is unnecessary in an orthogonal view. He disagrees with me. You can read his comments here. And so it brings us to this video. This is video I filmed about an hour ago. About an hour ago. Oh, look at me, I've doxed myself. Way to go. I have my dining room table, which is a flat surface, and I know it's flat because I can put round objects on it and they won't roll off in one direction or another. I know it's flat because it's my dining room table, and I can put other objects which I know to be flat on it, and I can see that there is no bowing, there are no imperfections to make this not count as a flat surface. I've measured the flat surface. I know how long my table is. And what I did is I took 4 drinking glasses and I set them up halfway down the table and at the far end of the table. Then I set my camera up on a tripod. The eyepiece of the camera was, or the lens of the camera rather, was 7 1/8 inches off the surface of the table. Each of the glasses is 5 1/8 inches tall, so that makes the total structure 10 1/4 inches tall. The first pair of glasses, the closer one here, are 30 inches from the front of the camera, and the further glasses are an additional 29 inches beyond that. I have my Theodolite app, and you will now see the angle at which I have to tilt the theodolite to reach the top and bottoms of these glasses. So I'll let that play. There's no audio on this, so you're not missing anything. So I tilt the iPhone up, and I keep going up. Then I tilt the iPhone down and keep tilting it down till I reach the other one. So what I've done here, and I'll go back to the individual timestamps that are particularly relevant. Okay. So right about here, we have a measurement of between 5.1 and 5.3 degrees. That is the angle up. I have to tilt the camera to have the crosshairs pointing at the top of the far set of glasses. I then tilt it further up, further up, further up, further up. I was a little hasty here, but we reach an angle of 7.6 degrees. And this might actually be off by a little bit more because you can see that the crosshair is still just slightly below there. So I think a reading of 7.7 or maybe 7.8 might be more accurate. I gladly do this again, no problem. Then I bring it down. You can see there we have 5 or 4.9 degrees. I'm not sure if I settled on 5 or 4.9. I think I settled on 4.9 perhaps. And then finally, coming down to the last one, gives us 11 degrees. So what we end up having here is a total of about 18.7 or 18.8 degrees of angular size for the closer set of glasses, and an angular size of about 10 degrees or 9.9 degrees for the further set of glasses. And you can visually see that I have to look further down to see the bottom of the closer set of glasses, and I have to look further up to see the top of the front set of glasses than I need to do for the further set of glasses. You'll also notice that that means looking at the ground when it's closer, I'm looking at a steeper angle, versus when I'm looking at the ground further away, I'm looking at a shallower angle. So what does all this mean? All this means is that this orthogonal side-on view is a perfectly accurate way of representing perspective. Okay? I have here the lens of the camera at 7 1/8 of an inch above the surface of the table. A is the camera. Okay? This blue object is the closer set of glasses, and this red object is the further set of glasses. Both of these objects are the same height. Both of them are 10 1/4 inches tall. The closer one is 30 inches away from the camera. The further one is an additional 29 inches beyond that. Not beyond the edge of this, but from this 30. So this one is 59 inches away, and this one is 30 inches away. The first thing we'll notice is that the angular size of this closer object is, according to this model, 19.307 degrees. The values I measured with my theodolite were about 18.7 to 18.8 degrees. And I'll explain why there's a discrepancy there in a moment. This further one, the angular size in this model is 9.918 degrees. 9.918 degrees is almost exactly what I calculated. I calculated a value, or I measured a value with the theodolite of between 9.9 and 10 degrees. So what we can see here is, within a reasonable margin of error, this model representation, this two-dimensional side-on orthogonal view of my tabletop with two identical pairs of glasses and the camera at the heights and sizes and distances that they actually are in real life, this is an accurate model. Now, why did I get a slightly smaller angular size when I used my theodolite for measuring the closer stack of glasses? I was off by nearly half a degree. Why would that be? And the answer is because when I was tilting my camera, I was not keeping the eyepiece, I was not keeping the lens of the camera exactly here. Instead, what ended up happening was, and let me just make sure. No, you can't see my mouse. That's a shame. So I wasn't keeping the eyepiece exactly here. It was moving slightly down lower and slightly up higher. And it was moving at a distance closer to or away from the glasses. So all this is to say, this side-on representation is accurate. I do not need to actually shrink the size of the distant glasses to get this side-on model to represent reality. That's all I wanted to say. Have a good rest of your day.